June 9th, 1993 was the last time a Canadian team won the Stanley Cup, the championship trophy of the National Hockey League. 1993 was a stupidly long time ago. For reference, the Canadian Cup drought is older than these guys. That's not to say that there haven't been close calls. Since 1993, 8 Canadian teams have made it to the Stanley Cup Finals, and 5 were even within one game of winning it. But none of them did. Now, there are plenty of theories as to why this is the case. Jim Benning, the larger proportion of American teams, income tax, Jim Benning, the fishbowl effect, the wrath of Gary, and Jim Benning. But we're not going to worry about the reasons for the cup drought. We're here to admire its unlikelihood. Today, we're going to use historical betting lines to analyze all of the Canadian teams during the cup drought. More specifically, by the end of this video, we're going to answer the following questions. How likely was this 32-year cup drought to happen in the first place? When did this 32-year cup drought officially become improbable? What teams were the most likely to end this cup drought? In what years did Canada have the best chance to end this cup drought? How many cups should Canada have had between 1993 and now? To start, I'm going to need to describe the methodology that I used for this experiment. You can skip over to the next section if you're just interested in seeing the results. Our calculations today are going to involve probability. The probability of an event is the likelihood that that event will occur. The majority of people describe likelihoods using words like a something percent chance. However, when we want to make calculations involving likelihoods, it is often best to use probability, which is the decimal form of a percentage or a fraction. To go from a percent chance to a probability, we can just divide the chance by 100, moving the decimal place 2 spots to the left. So, for instance, an event with a 50% chance of happening has a probability of 0.5. Now, why would we use probability instead of percentages? One good reason is that it's easier to use probability when working with multiple independent events that we want to combine in some way. We call a group of events independent if the occurrence of one event doesn't change the probability of another event. For instance, 2 different coin flips are independent because if you are flipping a coin twice, what you flipped the first time will not impact the probability of flipping heads or tails on the second flip. To determine the probability of 2 independent events occurring, you need to multiply the probability of the first event happening by the probability of the second event happening. So, for example, if we return to our coin flip, the probability of a coin flipping heads twice in a row would just be 1 over 2 times 1 over 2 equals 1 over 4. Or, in probability notation, 0.5 times 0.5, which equals 0.25. If we tried this with percentages, it would be more complicated. We can't just do 50% times 50% equals 2,500%. That doesn't make sense. 2,500% isn't a thing. We are going to be working with and combining a lot of numbers today, so it makes sense for us to use probability as our main way of measuring likelihood. We are going to be looking at every season played by a Canadian NHL team in the last 32 years, and we're going to be looking at every single Canadian team's probability of winning a cup in every single season since 1993. Now, is there an ironclad way of determining how likely a team is to win a Stanley Cup in a given year? No, definitely not. Hockey teams are extremely complicated, and it will never be possible to determine a cup probability objectively. But, in my eyes, the best public data to use to determine a team's probability of winning a Stanley Cup in a given year would be their betting odds going into the season. Now, I briefly want to disclose that I do not bet. I think gambling is extremely dangerous, and I think it's frankly disgusting that there are betting ads littered across every sports broadcast, especially since children are often watching. However, I find the math behind betting lines and point spreads to be very interesting. For each year since 1984, the website sportsoddeshistory.com has listed the betting odds for every NHL team prior to that season starting. This is probably the best objective data that we can use, but it likely isn't perfect. Remember, the main priority of bookies is to take your money, not give the most realistic NHL odds possible. These odds are listed by using something known as American odds. American odds are listed in the form of minus some number, if the team is favored, or plus some number, if the team is an underdog. In the preseason, every NHL team is an underdog to win the cup. It's inherently unlikely to win, so all American odds that we will see in this video are of the form plus some number. If a team is listed as plus some number, it means that betting $100 will give the bettor a profit of that number. The smaller that number is, the more likely bookies think that that team is to win the cup. As an example, let's talk about the first year of the Canadian Cup drought, the 1993-1994 NHL season. That year, the New York Rangers won the Stanley Cup. They were listed as plus 1,500 to win the Stanley Cup in the preseason. That means that if someone bet $100 on them during the preseason, they would have ended up winning $1,500 at the end of the season. Now, from these odds, you can calculate something known as an implied probability. For positive American odds, the way that you can convert to an implied probability is by taking the number 100 and dividing it by 100 plus whatever the betting line was. So, if we look at the 1994 New York Rangers, their implied probability to win the Stanley Cup would have been 100 divided by 100 plus 1,500, which is 100 divided by 1,600, which we can reduce to be 1 over 16, or in decimal form, the probability, 0.0625, which is the same thing as a 6.25% chance to win the Cup. Next, we will examine the betting lines of every NHL team across every season over the last 32 years. Let's start by focusing on the Canadian NHL teams in the 1993-1994 season. First alphabetically are the Calgary Flames, and they were listed as plus 1,200 going into the season. To determine their implied probability, we would take 100 divided by 100 plus 1,200, which is 100 divided by 1,300, which is 1 over 13. And in decimal form, that equals approximately 0.076923, or a 7.7% chance to win the Cup. The Edmonton Oilers were listed as plus 8,000 going into the season, so their implied probability would have been 100 divided by 100 plus 8,000, which is 100 divided by 8,100, which is equivalent to 1 over 81, and this is an approximately 1.23% chance of winning the Cup. The Montreal Canadiens won the Cup a few months before these odds were published, and Patrick Wall was still in his prime, so their odds were the best among all Canadian teams that season. They were listed as plus 600. In implied probability form, this would equal 100 divided by 100 plus 600, which is 1 divided by 7. Next up, the Ottawa Senators were coming off a season where they won 10 games and lost 70, so their betting line was listed as an astonishing plus 100,000. These are the worst odds that we're going to see today, and their implied probability was 100 divided by 100 plus 100,000, which is equal to 1 and 1,001. So very low, approximately 0.1%. The Quebec Nordiques had an emerging Joe Sakic and Matt Sundin on their roster, and they were listed as 1,200 going into the season, so their implied probability would have been 100 divided by 100 plus 1,200, which is equal to 1 over 13. And that's the same as the Calgary Flames. The Toronto Maple Leafs were coming off a Western Conference Finals appearance, and their odds were quite good, listed as plus 1,000, with an implied probability of 100 divided by 1,000 plus 100, which is roughly equal to 1 in 11. The Vancouver Canucks were very close to actually winning the Stanley Cup in 1994, and they were listed at a respectable plus 800 in the preseason, with an implied probability of 100 divided by 100 plus 800, which is roughly equal to 1 divided by 9. And finally, the Winnipeg Jets were considered major underdogs, listed as plus 6,000 going into the season, meaning that their implied probability was 100 divided by 6,000 plus 100, which is roughly equal to 1 divided by 61. Now that we know how to do this conversion, we can do it for all of the teams, and here's our table of all the individual probabilities of each NHL team. So, if we add all of the Cup probabilities of every NHL team together, it should total to 1. After all, a probability 1 is the same thing as an 100% chance of something happening, a guarantee of something happening, and there is an 100% chance that one of the NHL teams will win a Cup in a season. Not more, not less. However, if we add all of these probabilities together, all of the Cup probabilities, it equals a total probability of 1.55814, which in percent form would be an 155.8% chance. This doesn't make sense. The probability of something happening cannot exceed 1, it can't be more than a guarantee. The reason that the sum of all the probabilities here is greater than 1 is because of something called the overround. Remember, the main priority of bookies is to take your money. The overround exists to help bookies take your money. To show how the overround helps the bookie, I'll use an example. Suppose that an evil bookie is in his lab, devising the betting lines for the Great Pennsylvanian Coin Toss of 2025. Yes, that's a real thing. The lines he decides on are as follows. Heads plus 100. If the bettor places $100 on heads and wins, they will win $100. and the exact same bet for tails. So if the better places $100 on tails, and tails ends up being what the coin flips, they will win $100. Then, the implied probability of heads would be 100 divided by 100 plus 100, which is 100 divided by 200, which is the same thing as 1 over 2, which is probability 0.5 and 50% chance. And the probability of tails would be the same. 100 divided by 100 plus 100, which is 100 divided by 200, which is 1 divided by 2, which is 0.5, which is 50%. And that does make sense, considering how coin tosses work. If you flip a coin, there's a 50% chance it'll be heads, and a 50% chance it'll be tails. So the bookie did a good job giving realistic probabilities here. Now, let's say a lot of people want to take bets here. Let's say that 49 people place $100 on heads, and 51 people place 100 on tails. And now, let's assume that the coin does land on tails. Then, the bookie will receive 49 times $100, $4,900, from the heads bettors, but you'll have to pay 51 times 100, $5,100, to all the tails bettors. This means that the bookie lost $200 following the Great Pennsylvanian Coin Toss. Remember, the main priority of bookies is to take your money, and the bookie unsuccessfully did that after making these odds. Now, let's say the bookie instead made the following betting lines for the coin toss. Heads plus 50. So if the bettor places 100 on heads and wins, they will win $50. And tails plus 50. If the bettor places $100 on tails, and then the coin is tails, they will win $50. Now, the implied probability for both heads and tails is 100 divided by 100 plus 50, 150, which is 2 over 3, which is roughly 66.67% chance. These are not realistic probabilities. A coin obviously isn't more likely than not to land on heads. But let's consider the same scenario as before. 49 people place $100 on heads, and 51 people place $100 on tails. And let's assume, once again, that the coin lands on tails. Then, the 49 people who placed $100 on heads lost, so the bookie would gain 49 times 100 equals 4,900 from them. Then, the 51 people who placed $100 on tails won, but this time, they only get a profit of $50, so the bookie would have given them 51 times 50, which is 2,550, so the bookie gained $4,900, but lost $2,550, succeeding at his ultimate goal of taking your money. Now, we want all of the cup probabilities across every team to add up to 1. We want to get rid of the overround. So, we're going to use equivalent fractions to remove the overround and make something that we're going to call an overround adjusted probability. Our goal is for the sum of each team's cup probability to add up to 1. So, for each team, we can make a fraction of their implied probability divided by the sum of all of the implied probabilities. We want the denominator to equal 1, so we can use equivalent fractions. So, for example, the New York Rangers in 1994 had an implied probability of 0.0625. The sum of all of the implied probabilities that year was 1.55814. To change the denominator to 1, we have to divide 1.55814 by itself. Then, to change the numerator to the overround adjusted probability, we have to divide the numerator, 0.0625, by the same thing, 1.55814. Whatever we do to the bottom, we have to do to the top. If we do that, then our overround adjusted probability is approximately 0.040112, or 4%. Note that to protect my eyes, I'm rounding everything in this spreadsheet to 6 decimal places. So in this table, I've now put the overround adjusted probability for each team on the right side, and as we see, the adjusted probabilities all add up to 1, which is what we want. But we may see in future tables that the probability will add up to something very close to 1, but not quite 1, like 1.00003 or whatever. This is not an issue, this is just happening because of that rounding to the 6 decimal place, but it's not going to impact the numbers significantly. Now, in any NHL season, there's only one Stanley Cup champion. 2 teams can't win it at the same time. It is impossible for the Oilers, Senators, Flames, and Jets to win the Stanley Cup in the same season. Events that cannot occur at the same time like this are known as disjoint events, and these 8 events, each Canadian team winning a Stanley Cup, are all disjoint from each other. One thing that is really cool about disjoint events is that it's easy to calculate the combined probability of them. We can just add the probability of each event together, and that'll give us the probability of any Canadian team, any one of the 8, winning the Stanley Cup in a given year. So, starting in the 1993-1994 season, for example, we can add up all of these over-round adjusted probabilities of each Canadian team. If we do that, we get a total of 0.339161, or approximately a 33.9% chance of a Canadian team winning the Stanley Cup. So, right off the bat, that's a pretty good chance. As we talked about before, the way to calculate the probability of multiple independent events happening is to multiply all of their probabilities together, to take the product of them. We also know how to determine the probability of a Canadian team winning the Stanley Cup in a given season. But, how does that help us determine the likelihood of the Cup drought? If we do a calculation like taking the probability of a Canadian Cup win in 1994 times the probability of a Canadian Cup win in 1995 times the probability of a Canadian Cup win in 1996, all the way up to 2025, that just gives us the probability of a Canadian team winning the Stanley Cup in every year since 1994. But we want the probability of no Canadian teams winning the Stanley Cup from 1994 to now. So our equation should look something like this. The probability of no Canadian Cup in 1994 times the probability of no Canadian Cup in 1995 times the probability of no Canadian Cup win in 1996, all the way up to 2025. So, how can we find the probability of no Canadian teams winning the Stanley Cup in a given year? We can use something that is called the complement rule. The complement rule states that the probability of an event not happening is equal to 1 minus the probability of that event happening. So, for the 1993-1994 season, we determined that the Canadian teams had a cup probability of approximately 0.339161. That means that the probability of a Canadian team not winning the Stanley Cup in that year would be 1 minus 0.339161, which is equal to 0.660839. So, we now know our equation that we're going to use to calculate the probability of this cup drought happening, and we also know how to determine all of these numbers to plug into the equation. Now it gets fun, and we get to crunch the numbers. At this point, we're going to go through each individual NHL season during the Cup Drought, and we're going to look at the probabilities of the Canadian teams in these years, and the probability of the Cup Drought lasting from 1993 to that season. So, in the first season we looked at, the probability of no Canadian team winning the Stanley Cup was 0.660839. We are going to keep this number at the top of our screen, because our next calculation is going to depend on it. Next up, we're going to look at the lockout-shortened 1995 season. This was another year with some very strong Canadian teams, with Toronto, Montreal, and Vancouver being the standouts. Ottawa is there. If we add up all the probabilities of the Canadian teams, we get a total of 0.318755, which is a little less than the previous season, but still quite high. This means that the American Cup probability was 1 minus 0.318755, which is equal to 0.681245. Now, to find the probability of no Canadian team winning a Stanley Cup in either 1994 or 1995, we can take the probability of an American team winning in 1994 multiplied by the probability of an American team winning the Cup in 1995. If we do that, we have 0.660839 times 0.681245, which is equal to 0.450193, and in percent form, this would be approximately 45%. This means that by year 2 of the Canadian Cup drought, it was already improbable. If we are assuming that the betting lines are perfectly accurate, then there was a 55% chance that a Canadian team would have won the Cup in either 1994 or 1995. We are now going to put this number at the top of our screen to use for the next calculation. Now, get ready, because the late 90s are rough for Canada. Let's start with the 1995-1996 season. All of Montreal, Vancouver, Winnipeg, Calgary, and Toronto had worse preseason cup odds than in the previous year. Edmonton and Ottawa slightly improved, but their odds were still horrific. But the worst part of all of this is that one of the Canadian teams has now moved. The Quebec Nordiques are now the Colorado Avalanche, who win the Stanley Cup in their first season after the move. This season, the probability of a Canadian team winning the Stanley Cup was only 0.171627. To determine the probability of the Cup drought lasting from 1993 until 1996, we can take 0.828373, the probability of an American team winning in 1995-1996, and multiply it by 0.450193, the probability of no Canadian team winning the Cup in the previous 2 seasons. If we do that, we have 0.828373 times 0.450193, which equals 0.37928, the probability of the Cup drought lasting from 1993 to 1996. Alright, let's put that 0372928 at the top of our screen and go quick now. The 1996-1997 season was even worse. Toronto and Vancouver had worse odds than the year previous, and the Winnipeg Jets are now the Phoenix Coyotes. If we add up the probabilities of Canadian team winning the Cup, we are at 0.116609. So, the probability of the Cup drought lasting from 1993 to 1997 is 1 minus 0.116609 times 0.372928, which is equal to 0.3294411. The 1997-1998 season was somehow even worse, with no Canadian teams having better than 1 in 21 odds. The probability of a Canadian team winning the Stanley Cup this season was marked at 0.110951, less than a third of the odds in the 1993-1994 season. So, if we multiply the probability of an American team winning in 1998 by the probability of an American team winning in every year before 1998, we would have 0.292889. The 1998-1999 season was not much better for the Great White North. Montreal had the best odds in the country at about 4%, but every other team was a major long shot. One thing that we're about to see is a lot of new American teams being brought into the league. This season specifically was the inaugural season of the Nashville Predators. The odds were slightly better than the 1997-1998 season, but they were still around 11%. So, the odds of the Cup drought extending through the 1999 season were 0.292889 times 1 minus 0.112772. If you combine those, that's equal to 0.259859. At this point, it is 1999. The Coneheads are old enough to be sentient and to have done their cute little first day of school photo shoots, but they still have not seen a Canadian team win the Cup. In the 1999-2000 season, another American team was added, the Atlanta Thrashers, so now there are 28 teams in total, but only 6 in Canada. However, primarily due to the province of Ontario, Canada actually had their best odds since the 1996 season, with a probability of approximately 0.144405. Obviously, no Canadian team won the Cup this year, so the odds of the drought continuing through 2000 were 0.222334, so at this point, the Cup drought had less than a 1 in 4 chance of happening. The 2000-2001 season saw the debut of 2 new franchises, the Columbus Blue Jackets and the Minnesota Wild. However, given that expansion teams are typically horrible, all 4 of the recent expansion franchises aren't really impacting the odds yet. This season was very similar to the 1999-2000 season, with the Ontario teams leading the way and everyone else being a long shot. The probability of a Canadian team winning the Cup this year was 0.140127, and the probability of the drought lasting from 1993 to 2001 was 0.191179, putting us at less than a 20% chance. We are only in the year 2001. This number is going to get even more and more ridiculous. The Canadian teams might have been better in 2001-2002, but there was just some incredibly good competition around the league. Colorado, Detroit, Dallas, New Jersey, and St. Louis all had rosters littered with Hall of Famers, and they were consuming a large fraction of the probability pie. The Canadian teams had a Cup probability of 0.129531, and the probability of the drought lasting from 1993 until 2002 was 0.166415. The mid-2000s saw some very good Canadian teams, and we're going to see a significant improvement in the Cup probability for a few years. In the 2002-2003 season, there were no obvious powerhouses, but there also weren't any enormous underdogs. This season, the probability of a Canadian team winning the Cup was 0.164453, so the probability of the drought lasting all the way from 1993 to 2003 would be 0.139048. Note that we are officially at the 10-year mark. 2003-2004 was a really interesting year. With a Cup probability of 0.211146, this is the first time since 1995 that the Canadian teams had a better than 20% chance of winning the Stanley Cup. And in fact, a Canadian team did make the finals this year. Try to guess which one. If you guessed the Calgary Flames, who went into the season with the worst odds in the country, and approximately 0.62% chance of winning the Cup, you'd be right. They were very close, perhaps the closest of any team we'll discuss today. But, nonetheless, They did not win, and the probability of the cup drought lasting this long would have been 0.109689. There was no NHL season in 2004-2005 due to a lockout that never got resolved, so no cup was awarded, and the probability that the drought would last through 2005 stayed the exact same as the year before. Arguably, the most interesting season we'll discuss today is the 2005-2006 season. Following the lockout, the landscape of the league looked very different. Since the last NHL game was played, there were several rule changes, a salary cap was implemented, and multiple era-defining superstars were drafted. This was likely one of the toughest years for bookies to evaluate, but the Canadian teams were well respected this season. The Ottawa Senators brought in Danny Heatley and Dominik Hasek and had the highest odds amongst Canadian teams. The Calgary Flames received way more love from the bookies this time around. The Canucks and Maple Leafs were also well respected, and nobody had laughably bad odds. Collectively, the probability of a Canadian team winning the Stanley Cup in 2005-2006 was approximately 0.262705. However, this season was downright bizarre. For the second consecutive season, a Canadian team with the worst odds in the country ended up making the finals. The Edmonton Oilers ended up making the Stanley Cup final, and losing in 7 games to the Carolina Hurricanes, who were tied for the second worst odds in the entire league. And it gets even weirder. The final 4 teams standing all had bottom 10 cup odds going into the season. But as unique as this year was, the end result was not unique for Canada, and the probability of the cup drought lasting this long would have been 0.080873. So now, the cup drought had less than a 10% chance of happening. The Canadian teams remained very competitive going into the 2006-2007 season. None of them were disrespected by the bookies, and Ottawa had the best odds of anyone in the entire league. Altogether, the Canadian teams had a cup probability of 0.245753. After whipping massively in the past season, it appears as if the bookies did a better job in 2007. The final 4 teams standing were in the top 6 for cup odds in the entire league going into the season, and the Ottawa Senators did end up going to the finals. However, they ended up losing in 5 games to the Anaheim Ducks. The probability of there being 0 Canadian Stanley Cups from 1994 all the way through 2007 would have been 0.060998. Even though Ottawa was still a powerhouse, the 2007-2008 season was a turn in the negative direction for Canada. For the first time since 2003, the chance of a Canadian team winning the Cup was under 20%, with a probability of 0.199326. And also, for the first time since 2003, there weren't even any Canadian teams in the finals. The probability of the cup drought lasting this long would have been 0.04884, less than a 5% chance. And we are officially at the 15-year mark now. Montreal became the favored Canadian team prior to the 2008-2009 season with a cup chance of about 6.9%. However, Canada as a whole was considered less likely to win the Stanley Cup, with a combined probability of 0.18531. The probability of the cup drought lasting all the way through 2009 would have been 0.039789. The downward trend continued going into the 2009-2010 season, with the province of Ontario in a dire state. The probability of a Canadian team winning the Cup this year was only 0.163818, and therefore the probability of the drought lasting from 1994 to 2010 would have been 0.033271. The 2011 Vancouver Canucks are likely the best individual team we will discuss today, but the odds of a Canadian team winning the Stanley Cup as a whole didn't really change, with a combined cup probability of 0.168904. This season, the Canucks had the best record in the regular season, made it to Game 7 of the Stanley Cup Finals, but did not win. The probability of the drought continuing beyond the 2011 season would have been 0.027651. The 2011-2012 season saw the return of the Winnipeg Jets, so instead of 6 Canadian teams, we now had 7. But this did not have a major impact on the Canadian Cup odds. For the 2011-2012 season, the Vancouver Canucks were on an island, and Canada only had a cup probability of 0.188902. The LA Kings won the 2012 Stanley Cup, and the probability of the drought lasting this long would have been 0.022428. The lockout-shortened 2013 season was more of the same, with a Canadian Cup probability of 0.179079, and the Vancouver Canucks easily having the best odds in the country. This season, the Chicago Blackhawks had one of the more dominant seasons in recent memory, winning both the President's Trophy and the Stanley Cup, ultimately extending the Canadian Cup drought. Our magic number becomes 0.018412. The 2013-2014 bookies were slightly nicer to the Canadian teams, with a Canadian Cup probability of 0.184955, and everyone except the Calgary Flames and Winnipeg Jets were decently represented. The LA Kings continued their string of success with their second Stanley Cup in 3 years. The probability of the cup drought lasting until the 2014 season would have been 0.015007. The 2014-2015 season was another weird one. The combined cup probability of the Canadian teams was 0.117637, which is one of the lowest numbers we've seen so far. However, the Canadian teams didn't play too bad this year. 5 of the 7 teams ended up making the playoffs. As nice of a story as that might be, we do not care about the playoffs. We only care about the Stanley Cup, and the Stanley Cup went to the Chicago Blackhawks. The probability of the drought continuing for this much time would have been 0.013242. Given the relative success of the Canadian teams in 2014-2015, it was inevitable that Canada would have a greater cup probability in 2015-2016. Going into this season, the combined Canadian Cup probability was 0.152737, still not great, but better than the year before. Now, how did the Canadian teams react to this extra respect from the bookies? By sucking, apparently. For only the second time in NHL history, no Canadian teams even qualified for the playoffs. The probability of no Canadian team winning a cup from 1994 to 2016 would have been 0.011219. Unsurprisingly, the bookies were not kind to the Canadian teams going into the 2016-2017 season. Nobody had very good odds, and the Canadian Cup probability was 0.113212. The Canadian teams continued their run of weirdness and unpredictability, with 5 of the 7 teams qualifying for the 2017 playoffs, and the Ottawa Senators within 1 game of the Stanley Cup final. However, none of them ended up winning the Stanley Cup, and the probability of the cup drought continuing through 2017 would have been 0.009949, meaning that there was less than a 1% chance that no Canadian team would win the cup from 1994 to 2017. The 2017-2018 season is another one that had some very, very wacky results. Going into the season, the probability of a Canadian Cup was 0.235133, largely because the Toronto Maple Leafs and Edmonton Oilers had some extremely good young core players. This was the inaugural season of the Vegas Golden Knights. Like some of the other expansion teams we've looked at today, the Golden Knights had horrific cup odds going into the preseason. But the entire hockey world misfired, and the Golden Knights made the Stanley Cup Finals in their first season. The weirdness doesn't stop there, though. Of the teams with the bottom 5 odds going into the season, 3 of them made the playoffs, and the Edmonton Oilers, with the second best cup odds of the entire year, finished bottom 10 in the NHL. Once again, the cup remained south of the border, and the probability of the drought lasting from 1994 all the way up to 2018 would have been 0.00761. The Canadian Cup odds in 2018-2019 were relatively similar going into the season, with a Canadian Cup probability of 0.229279. However, no Canadian teams even made it out of the first round of the playoffs, and the probability of the cup drought making it this far would have been 0.005865. The 2019-2020 season ended in a really strange way due to the pandemic, but there was nothing too abnormal about this year from a probability perspective. The Canadian Cup probability was 0.195443, the heavily favored Tampa Bay Lightning ended up winning the Stanley Cup, and the drought ultimately continued. The probability of the drought lasting this long would have been 0.004719. This officially puts us at less than a 1 in 200 chance. The pandemic-shortened 2021 season was not much different. The probability of a Canadian Cup was similar at 0.193051, and once again, the Tampa Bay Lightning, with excellent odds, win the Cup. Who did they defeat? The Montreal Canadiens, who went on a massive Cinderella run, but couldn't finish the job. The probability of the cup drought lasting this long would have been 0.003808. A new American team, the Seattle Kraken, was introduced before the 2021-2022 season, meaning that there were now 7 Canadian teams and 25 American teams, much different from the 8 Canadian teams and 16 American teams that we saw in the mid-90s. From a probability standpoint, this was another unremarkable year for Canada, with a combined cup probability of 0.181-019. The Colorado Avalanche ended up winning the cup, and our magic number is now 0.003119. Largely due to the excellent cores of Toronto and Edmonton, the Canadian teams had a pretty good chance going into the 2022-2023 season, with a combined cup probability of 0.234894. The Vegas Golden Knights, only in their 6th season, ended up winning the Stanley Cup, and the probability of the drought lasting this long would have been 0.002386. For similar reasons as the last season, the Canadian Cup chances remained respectable going into 2023-2024, with a probability of 0.230602. The Edmonton Oilers ended up making the Stanley Cup Finals, forcing 7 games, but ultimately losing to the Florida Panthers. The probability of the drought continuing past the 2024 season would have been 0.001836. And most recently, the 2024-2025 season was shockingly similar, with a probability of 0.234902, with Edmonton and Toronto being the most favored. The Edmonton Oilers, once again, made the Stanley Cup Finals, and once again lost to the Florida Panthers. And now, for the grand total, the probability of the Canadian Cup drought lasting for all of the last 32 years is 0.001405. In percent form, that's equal to roughly 0.14%. I checked my document many times for potential errors and even corrected some, but I cannot be 100% sure that I input every number correctly. However, I can say that any potential input error should not be impacting this number significantly, and if this is not the exact number, it must be very close. In fraction form, this would equal 1,405 over a million, which as a unit fraction is approximately equal to 1 in 711. This means that if you were to simulate the past 32 years 711 times, then we should expect to see a Canadian Cup win in 710 of them. The Coneheads are now 32 years old. They have a college degree, 2 kids, and a lifetime of alimony payments ahead of them. But they still have not seen a Canadian Stanley Cup. We've crunched all the interesting numbers, so let's quickly go through some other cool information that we found. During this process, we've not only found the probability of any Canadian team winning a cup, but we've also found each individual Canadian team's probability of winning a cup in a given season. And we can put all of our results in a table like this. So here is our table. The row represents the season, and the column represents the team. So, for example, this cell right here is the probability of the Calgary Flames winning the cup in the 1993-1994 season. Now, to calculate the probability of a specific Canadian team not winning a cup between 1993 and now, what we can do is take the products of the probabilities of this team not winning the cup. And the way we determine the probability of a team not winning the cup in a given season is just to use the complement rule again. We take 1 and we subtract the team's probability of winning the cup that year. So, for the Flames, for example, the probability of a Stanley Cup in 1994 was 0.049368. So, the probability of any other team winning the cup would be 1 minus 0.049368. That is equal to 0.950632, so about a 95% chance of the Calgary Flames not winning the cup. Using Google Sheets, we can use the command array product 1 minus cell range. In the case of the Calgary Flames, it would be G3 all the way up to G33. And using this command, we can quickly calculate the probability of the Calgary Flames not winning a single Stanley Cup during this stretch. If we do this, we will get the probability of the Flames never winning the cup from 1994 to 2025. And in this case, this equals 0.483561. So, to find the probability of a team winning at least 1 cup in this time frame, we can use the complement rule again. So to find the probability of the Flames getting at least 1 cup in the last 32 years, 1 minus the probability of the Flames getting 0 cups. So 1 minus 0.483561. And if we do that, our answer is 0.516439. This is the probability of the Calgary Flames getting at least 1 Stanley Cup. It could be more, but at least 1 in the past 32 years. So for each Canadian team, we're going to do a similar calculation. We're going to take 1 minus the probability of that Canadian team winning 0 cups from 1994 to 2025. And that's going to be the probability of the Canadian team having at least 1 cup in the last 32 years. In 8th place are the Quebec Nordiques. This is hardly surprising considering they haven't existed for 30 years, but they only had a probability of 0.082, 2-1-1 of ending the Cup drought, which would be either winning the Cup in 1994 or 1995. Next up, we have the Winnipeg Jets in 7th place. The Jets were not in the NHL for 10 years, so this obviously has impacted their chances significantly. The probability of the Winnipeg Jets winning at least one Cup in the past 32 years is listed as 0.293786. Now, we have 6 teams left, and all 6 of these teams have been in the NHL every year during the Canadian Cup drought. In 6th place, the lowest ranking of the teams that participated in every season during the Cup drought, are the Calgary Flames. As we calculated before, their probability of at least one Cup win was 0.516439. This means that all 6 of the remaining teams had more than a 50% chance of winning at least one Cup from 1994 to 2025. For 5th place, we're staying in the province of Alberta with the Edmonton Oilers. This may seem surprising. Since 1993, the Oilers have made 3 Stanley Cup finals, more than any other Canadian team, and they currently have a generational talent on their roster. However, they were very weak from the mid-90s up until the late 2010s, and their 2006 season was considered to be a major underdog story. Their probability of winning at least one Cup from 1994 to 2025 was 0.537817. In 4th place, we have the Ottawa Senators. They've had some rough years in recent memory and were a complete joke in the 90s, but they had some very competitive teams in the mid-2000s. Their probability of winning at least one Cup from 1994 to 2025 was 0.557586. In 3rd place, we have the Canadian team that last won a Stanley Cup, the Montreal Canadiens. They had elite goaltending for a large percentage of the Cup drought, and that always gives your team a chance. Their probability of winning at least one Cup from 1994 to 2025 was 0.593657. There are 2 teams left, and the fans of the teams that were already mentioned are surely snickering at this point. In 2nd place, we have the Vancouver Canucks. They boasted some very good teams in the early to mid-90s, as well as the early 2010s. The 2012 Canucks had a higher Cup probability than any other Canadian team during this Cup drought, so it's not a surprise to see that they're high on this list. Their probability of winning at least one Stanley Cup from 1994 to 2025 was 0.652666. And then there was one. I'm sure many people have figured out who this team is. I frankly was shocked when I saw this result. The Canadian team most likely to have won a Cup at some point from 1994 to 2025, if we are going by these betting odds, is the Toronto Maple Leafs. Their probability of having won at least one Cup from 1994 to 2025 is 0.724901, roughly a 72.5% chance. What makes this weird is that of the 6 teams that have been in the NHL every season during this Cup drought, Toronto is the only one that never even made a Stanley Cup final. However, if we look at Toronto's chart, there's a few things we can observe. The bookies gave the Leafs a very good chance of winning the 1994 and 1995 Stanley Cups. This makes sense because in the years prior, 1993 and 1994, they had made the conference finals. Following the hiring of Pat Quinn in 1998, Toronto was a consistent playoff team and had another pair of conference finals appearances. Unsurprisingly, the bookies were not very high on the Maple Leafs from the mid-2000s to the mid-2010s, but after Mitch Marner, Austin Matthews, and William Nylander were drafted, the Leafs became an elite regular season team, and the bookies started to respect them again. Though I didn't expect them to be first on this list, the Toronto Maple Leafs have certainly had their competitive stretches in the last 32 years. And in case you want to see a chart like this for every team, I'll just put it on the screen right now. Now, if you recall, for the 1993-1994 season, we went through the step-by-step process of calculating the Canadian Cup probability, and determined that there was about a 33.9% chance of a Canadian team winning the Stanley Cup in that season. As it turns out, that was the most likely season for a Canadian team to win during this Cup drought. This shouldn't be that surprising, given that's when the proportion of Canadian teams was at its greatest in the last 32 years, but it's still depressing. The late 90s were the worst time for Canadian teams. 1997 and 1998 was the worst season in particular, with a Cup probability of about 0.110951. During this stretch, the average Canadian Cup probability was around 0.188906, and the median was very similar as well. This average is lower than the fraction of Canadian teams in the league overall, so this does suggest that some of this drought is just that the Canadian teams have been kinda bad. Obviously, Canada should have won at least one Cup in the past 32 years, but should they have won more than one? The way we can check this is to calculate the expected number of Cups. To calculate the expected value, you add up each possible outcome multiplied by the probability of that outcome happening. So, in the 1993-1994 season, the expected number of Canadian Cups would be calculated as follows: 0 Stanley Cups times the probability of an American team winning, plus 1 Stanley Cup times the probability of a Canadian team winning it. In 1993-1994, the probability of a Canadian team winning the cup was 0.339161. So the way we would calculate the expected number of cups would be 0 Stanley Cups times 1 minus 0.339161 plus 1 Stanley Cup times 0.339161, which equals 0.339161 expected Stanley Cups. And in this case, the expected value is actually very simple to compute. So now, what we want to do is add the expected number of Stanley Cups together across all seasons. And in this case, the number of expected Stanley Cups for Canadian teams in a given season is just the same as the Canadian Cup probability. So, to find the number of expected Canadian Cups, we can just add up all of the Canadian Cup probabilities together for each individual season. So if we do that, our total is approximately 5.85 expected Stanley Cups. So, Canada shouldn't have just gotten 1 Stanley Cup in the past 32 years. They probably should have gotten 5 or 6. So, there we have it. We've answered every single question that we set out to find at the beginning of the video. I've left a copy of the document in the description, and I'm sure there's other fun things that people can play around with if they'd like. But, to quickly summarize, the Canadian Cup drought has been extremely unlikely, and at this point the Coneheads might never see the Stanley Cup return north of the border. If you're interested in this kind of content, I'd recommend subscribing. Next up is a similar video, but this time we're going to pick on some sports teams south of the border.